Great. We are also live streaming on YouTube. Hello, everyone, and thank you for joining. We will just give a couple of minutes for everyone who's registered. We have over some 250 registrants for today's webinar from different parts of the world, which is quite impressive, and it's also kind of a clear indicator that the topic is gaining momentum and popularity amongst our community. I see a couple of familiar names joining us live, which is really awesome. Please feel free to connect with me here or by email if you'd like us to bring together different topics of interest. So please feel free to make those kind of suggestions. As you know, these are free webinars, and we try to explore various topics that could be of interest and used to not only the publishing community, but also the research community as a whole. So yeah, please share your thoughts, which will definitely help us brainstorm topics for future. So perhaps as we wait for everyone to sort of join in, let me very quickly make some introductions and run you all through the usual housekeeping. The audience is muted by default, but that should not, and that doesn't stop you from connecting directly with the panelists. So please use the Q&A box, Q&A section for questions, any questions that you may have for the panelists. Please, let's try to use the chat for the chat, so keep those comments flowing, but let's try to use the Q&A section for just the questions, which will be kind of very helpful later on when sorting through all the questions for the Q&A section. So I'm Sally Kanaka. I'm the Scholarly Communications Manager at MyScienceWork. We work very closely with research institutions and publishers and also researchers across multiple facets. The scientific communications team helps with the dissemination and popularization of research with a global community of 1 million members. Publishers also index content within the MyScienceWork database. And finally, for advancements in scholarly output discovery to exist, systematic content structuring, clustering, and categorization must evolve. And that's exactly where the MyScienceWork data scientists come in. They work very closely with publishers and institutions to make this reality. And so if you're interested in learning more about AI tools for entity recognition systems, for semantic search, to explore advanced semantic publishing, please you can visit us on mysciencework.com, or you can drop an email. So that will be contact@mysciencework.com. So moving on to today's discussion, it's one close to our hearts here at MyScienceWork, because we work a lot in terms of AI tools to advance scientific scholarly publishing. We aim to discuss how AI is changing and how it will go on to redefine the scholarly communication landscape. Our panelists will also share some tools that they are currently using on this front, discuss some challenges and opportunities. So again, here's one for you all to pitch in with your experiences. A quick introduction to our esteemed panelists. I'm absolutely thrilled and honored to have with us today Dr. Joris Rossum, Dr. Phil Gooch, and Dr. Myram Eckert. So for the few of you who aren't familiar with these names, Dr. Joris Rossum, he's the STM's Director of Research Integrity, where he supports and coordinates STM's research integrity and data programs. He has worked for several leading companies and organizations across the STM's publishing space, including Digital Science and Elsevier, where he initiated and led a variety of important innovations and cross-publisher initiatives within the research and publishing ecosystem. Dr. Rossum holds a master's degree in biology and a PhD in philosophy. Dr. Phil Gooch, he is the founder and the architect of Scholastic. He has previously led NLP teams for a number of startups and has over 20 years of experience developing content enrichment and automated knowledge extraction solutions for publishing, but also for education, legal, and healthcare sectors. So it's really an absolute treat to have someone with such extensive technological expertise joining the discussion. Last but definitely not least, we have Dr. Myram Eckert. She is the Chief Publishing Officer at Frontiers. So it's wonderful to have you here. Dr. Eckert oversees the journal launch and development, as well as the peer review of Frontiers, working very closely with technology teams on developing the Frontiers open science platform. She joined in 2014 as the journal manager, but she also led the Frontiers editorial team from 2015 and became the publishing director in 2019. She has a PhD in molecular biology, and since 2010, she transitioned into academic publishing, so joining the Open Access Journal of the International AIDS Society and as managing editor. Since then, she has held various positions, including that of the council member and trustee of the Committee of Publishing Ethics, so COPE, where she was the chair of the outreach committee for several years. So on behalf of My Science Work and all of you joining us live or watching the replay in the future, I'd like to extend a very warm welcome to each and every one of you. Diving straight into the topic, AI-based solutions are pretty much everywhere. It's quite prevalent in major publishing businesses, and all the signs indicate a clear upward trend. So what could be a first good step would be to discuss what AI in publishing refers to, and then sort of narrow it down to what's happening at the moment in terms of its role and also its implication in scholarly publishing. So I don't know, Joris, would you like to hop onto it?
Yeah. Well, first of all, thank you very much for the invitation. It's really nice to be in this session today. I'm looking forward to the discussion. So yeah, the topic of AI and publishers. Actually, publishers engage with AI on various levels. First of all, publishers are key providers of data on which AI is run. Relevant, high quality training and input data is, of course, essential for AI. They are the key ingredients of high quality outputs, and providing that data in the required digital format is, of course, the core expertise of publishers. Second, and we're going to talk about this today, of course, we are increasingly using AI in our workflows, supporting editors, authors, reviewers. For example, AI is being used also by our members in recommending journals to authors, recommending reviewers to editors, streamlining submissions, doing technical language checks, etc. Increasingly, publishers are using AI to detect fraud, manipulation, and plagiarism, spotting suspicious patterns. And in that complex area, collaboration is key, both on sharing content, sharing tools, developing tools, but also making sure that all publishers, and STM represents about 150 scientific, technical, medical publishers, that let's say the larger ones, but also the smaller and the mid-sized publishers have equally access to the tools detecting frauds. And we all know the topic of paper mills, of course, which is very much related to this topic of AI, both in the production of fraudulent science as well as the detection. So STM actually started a project late last year called the Collaboration Hub for Research Integrity. And it's basically a virtual environment we're building where trusted algorithms and AI can access content and screen for research integrity issues, but also an environment where we can develop those tools in collaboration between publishers, STM Solutions, who is building the tool, but also, of course, the results of those algorithms, of those tools, can be fed to the editors to help them make decisions. Talked about two aspects of AI and publishers. There's a third one, of course. We are increasingly deploying AI in externally facing tools, using it to classify content, to recommend, to make it easier to process and digest all those millions of articles, but also bringing together multiple sources, for example, also as input for an R&D for the pharmaceutical industry. So I would say it's extremely relevant for society at large, but especially for publishers.
So, you talk about recommendation systems. That's what you meant earlier.
Sorry,
in terms of creating recommendations.
Yeah.
So you meant recommendation systems for research content.
Yeah, it is. Yeah.
Okay, great. Mayam, would you like to hop in at this stage and kind of share your experience and your thoughts on the topic?
Yeah, of course. Also very nice to be here. Of course, I mean, we all know that the publishing landscape is evolving fast, and the publishing output is exponentially increasing. So we're at around 4 million articles now in 2021 and counting. And of course, we're all interested in making sure that this scientific literature is rigorously quality controlled, and there is an efficient publication process that disseminates this research. So there's this myth, of course, that volume and quality can't go together. And that is actually a completely wrong assumption. And, you know, AI can actually play a really important part in ensuring that we can ensure the quality of these articles being published while also providing an efficient author service. So there's always this thing about cool new technologies that people really like to jump on the bandwagon on and throw around these terms. But there's actually no magic behind AI necessarily. There's actually a lot of hard work and development that will go into it. Phil will probably talk about that. An awful lot of testing, trial and error as you implement these types of solutions. But the strengths of AI are really applicable to publishing. So you have the strengths of pattern recognition. That also means it can detect anomalies. It can classify content. It can do the recommender systems, as we heard. It can do predictive analysis and decision support for people. So there's a lot of applicabilities of AI in publishing. And the good news is that in publishing, actually, our data is very structured. So obviously, we have quite standardized way of publishing. Then, of course, there's another layer of, and we're going to talk, I think, about challenges later about obviously the content accessibility and how machine readable this content actually is. For us, you know, the expectations are high. You know, we want to be faster, more efficient, rigorous. So the stakes we feel are high in it. And we really started off just with advanced algorithms, like everyone, you know, trialing some machine learning algorithms to recommend reviewers. And then we continuously leveraged the AI technology as it itself was evolving to assist our editors, authors, reviewers, and our editorial staff. And we created a product called Ira. So we brought this together into a product called the AI Review Assistant, so Ira. And so to leverage these different use cases, and we plug her into our open science publishing platform. And yeah, I'm sure I'll get a little bit more chance to talk a bit more about Ira and what she can do right now. But yeah, the beginnings are here, and we're learning a lot as we progress. So yeah, exciting times.
So yeah, looking very much forward to listening and learning more about ARA, because that kind of is one of the goals of this webinar, to discuss tools that exist, and ideally open source tools that exist out there to put into work. Phil, did you want to comment on this?
Yes, thanks very much, Sally. It's great to be here, and thanks for inviting me. I thought it might be useful just to take a step back and look at the history of AI in publishing and how we got to where we are now. Because it didn't come from nowhere. It's actually been part of a continuous process that publishers have been investing in for many years. And it wasn't always called AI. So, I mean, the broad definition of artificial intelligence, you know, is focused on the idea of autonomous agents making things like goal-directed decisions as a result of interacting with and analyzing their environment. And it encompasses things like computer vision, audio and text processing, and remote sensing. So that's kind of like the textbook definition of AI. But within scholarly publishing, we have a much narrower view, and it is very much, as Miriam said, it's pattern recognition. This is predominantly what we're doing in publishing and in this industry is pattern recognition for images. So to identify things like plagiarism in images, plagiarism in text, or manipulation of images, learning patterns in text to identify and correct things like grammar and spelling, or doing things like learning mappings between one sequence of text and another sequence of text to do things like automatic translation from one language to another, or do things like mapping a technical document into maybe more of a plain language summary for a wider audience. So this use of pattern recognition has a long history in scholarly publishing, and before, you know, the AI buzzword, we talked about text processing, semantic enrichment, those sort of words, but they were using the kind of the forerunner of what we call AI now. Typically, in the early days, publishers, some of the larger ones certainly would have teams in-house of editors working on screen, tagging information up, and using things as simple as word macros in many cases, just to automate some repetitive tasks. And that could be doing things like putting text into house style, from simple as like italicizing the words et al, for example, wherever they're found, to doing all sorts of more complex checks. Back in the 90s at Routledge, we had a system all based around Microsoft Word that would do the tagging. It would even do the typesetting in Microsoft Word or export the data to be typeset in Quark Express or other typesetting systems. And none of that was using AI, but it was using rules that subject experts would write and then were encoded by engineers. Now, the good thing about rules is that they're very effective, as they can be written by subject experts, translated by computer scientists, and the results are transparent and explainable. And AI systems today still use these rules, but they use them now in the context of machine learning as well. So a typical AI system in publishing will use machine learning to learn from labeled data to better predict things like, to do things like recommendation and classification and other things. But on top of that might be a sequence of domain-specific rules that really refine the output and make it more accurate. So with your model, you might get to maybe 80, 85, 90%. And then with your rules, you can really push that up higher to 95, getting towards 99% accuracy. So AI systems have evolved over the last 20, 30 years into what we see today. And they're much easier now to develop, thankfully, than they used to be. And I think that's why we're seeing that explosion in interest and the use of AI in publishing. Thanks, Phil. It's always great to have a history lesson, regardless of what we talk about the topic. So thank you for that. As Mariam said, content is multiplying before our eyes. This statement stands true for research material that's published online as well. We are at something like 4 million articles published worldwide in 2017 alone, with no signs of slowing down. So with reading time declining, content creation multiplying, how do the panelists see AI solving the problem of too much information and too little time to read? What tools exist that could help track this problem? Maybe Mariam, you could jump into this question, because I know that you are currently working on IRA, and it would be really fantastic to hear what you have to say about IRA and share that with us.
Sorry, the dog. Would you like me to give the presentation now about how we use IRA, or would you like me to comment more on matching sort of readers with content?
Yes, we could start off with that kind of comment, what your thoughts are on that, and perhaps this could be also a time to hop onto the presentation of IRA and see what IRA can do.
Yeah, so I mean, obviously my comment is that this is one of the best use cases for AI is to match people with content. I mean, the semantic analysis behind the technology is really powerful nowadays. And this is where we see a lot of value in the future for this technology, because, as you say, there is an increasing amount of information out there, and directing people to the right content, if it be reviewers with manuscripts or readers with articles, they all follow the same logic. In terms of the IRA itself, so we currently don't offer sort of like reader services to link them to content, but we use IRA, of course, to suggest reviewers to handling editors. So if you want, I could sort of show a little bit around
Yes, that could be great, but if you could try to kind of, because I know that there are some questions that will be coming in later on, so if you could kind of have the best parts of IRA up and going, that would be fantastic.
Okay, let me click a few buttons here. Okay. So technology has always been at the heart of our operations at Frontiers, and we see technology really as something that has to work together with humans. So the technology is never going to take over. It's really there to empower humans and to enhance what we're trying to do. So I mentioned IRA already. As a product, we have two use cases for it. One is on quality checks, one is on the expert recommender. And obviously, what we talked about at the beginning is that AI needs data, very good data to work. And so for us, IRA sits on top of a knowledge graph. that curates the type of information that is out there on the publications, the researchers, citations, organizations. And the trick behind it is, of course, is to have this knowledge graph that combines a lot of the different databases that are currently out there and links them together. So you can see objects here in space that are linked with connections such as citations, similarity scores, and so on. So in terms of quality checks, IRA has really been able to help us scale up our quality checks. So we do a lot of checks on the manuscript as it's being submitted, and then during peer review. So there's two elements of it that ranges, as we mentioned, from plagiarism checks to image manipulation, and so on. And 13 of these checks are now currently powered by IRA. It flags manuscripts that require the attention of our editorial office, and then it goes into a human validation phase. So there's 100% transparency over the decisions that are being taken, and everything is being recorded as well. So you can see the type of interface that we've built, and this interface is actually really important, and I'll come back to that in a minute. Image manipulation is a great pattern recognition example for AI. So it obviously looks for similarities in images, and that can also detect things that have been stretched, rotated, or have had slight modifications that are actually sometimes quite hard to spot by human eye. There's some good people on PUB here who do that, but there's a good application here for AI. And the idea is to visualize that for the team, to flag it, and then the team will come in and they will actually validate the flag, and they give feedback to IRA. So this is really important because the feedback helps it to learn. So whether it has flagged the right thing. Face detection is similar. So it uses here a neural network, convolutional neural networks. That's actually quite a standard technique now, where we train it on a sample data set, and it will learn how to recognize human figures and images, and it will flag them, and then the team can check for the appropriate consent forms and so on. So the team members, again, they pick up these red flags as they come in, and they will process the manuscript, they will look at the image, and then they will provide the feedback. And then the idea is, of course, that all these checks have to be resolved for the manuscript to move into peer review. So we don't waste any reviewer or editor's time with manuscripts that haven't passed this quality check. The other area is the expert recommender. And this is around obviously matching manuscripts with experts in the area and suggesting them to handling editors. We provide these types of cards, and really the trick behind it, and that's again coming back to this interface thing with AI, it's not just about the technology that can be as smart as be, but you need to be able to provide people with a way of interacting with the technology and to feel in control. That really helps adoption of this type of technology. So what we do is people can click on a person's profile, they see why the technology recommended this expert for the manuscript, and they can even change the algorithm, so they can remove keywords, they can make the weighting higher, and then they can filter down or add new keywords. So they have full control over the recommendations, and then it just gets updated in real time for them. So yeah, so just that was a real, in a nutshell, type of run through IRA. And obviously it's about maximizing quality at scale, augmenting human decision, enhancing humans, and giving time back to researchers. So that's really the aim of the technology that we have at Frontiers.
Great. And for those of you maybe who wish to have more information about IRA, maybe they could get in touch with Mariam, and she'd be happy to share more information on that front. I'm sure, Phil, you have a lot of thoughts on this topic, given your 20 years of extensive experience with the technology. So what are your thoughts? Where do you stand on this?
Yeah, thanks, Sally. Well, also thanks, Miriam, for sharing the overview of IRA. I hadn't seen that before. It looks really fascinating. I thought it might be useful just to share like a picture of the ecosystem of the tools that are available for building.
Yeah, please do.
System. Let me just share my screen. So where are we? So apologies, Miriam, Ira's not on this. So I prepared this before I'd seen it's a rich ecosystem of tools that are being used throughout the scholarly publishing cycle. So here's just a few of them here. So, you know, at the manuscripts creation stage, we've got tools such as PaperPal, Writeful, Grammarly, and so on, AJE editing, that, you know, help the author prepare their manuscript. They do the language checking, the correction, make suggestions and so on for writing styles that are pertinent to, you know, academic publishing. And then at the submission stage, as we've seen, we've got systems like IRA, but there's other systems that publishers developing. People like Hindawi have a system that does some manuscript checks, and we've got metadata extraction being done by Taylor and Francis and Sage, for example. And as well as doing the screening and checking, it's also helping authors, having a smoother process for authors at the submission stage. For example, if your manuscript already has the abstract and the affiliations and the references in it, why should the author have to rekey that information into the submission system? It should be possible to extract that information directly from the manuscript, no matter what format the manuscript is in, whether it's PDF or Word or something else. It should be possible to use AI to extract that information and automatically populate the submission field. And indeed, that's what a number of publishers are working on now, in collaboration with external partners. And then you've seen we've got the technical checks, as we saw with IRA. And there's other tools like SciScore that do specific things for biomedical research in terms of reproducibility, and if you mentioned your reagents correctly and so on. And then other checks such as things like, is there a funding statement, limitation statement, data availability statement, and so on. And then when we come to the dissemination access side, over on the left here, we see, as we heard at the beginning from Joris and Miriam, AI has a long history in terms of indexing, search engine optimization. So that would be extracting keywords for indexing in Google, for example, and for building recommender systems. And, you know, for example, My Science Work are a good example of that, as well as other systems by Unsilo and TrendMD. But I thought I'd highlight on the top left-hand corner here in red some of the newer tools, because it's not just about using AI for the production process and the screening and the science process of research. It's also about how do you present that information to the reader in the best way that helps them explore that information, connect it, join the dots, and understand it. And so we're seeing the emergence of new tools, such as Cite AI, Connected Papers, and Research Rabbit, that are aimed at the consumers of scholarly research. They're aimed at, you know, undergraduates, masters, postgraduates, and above, to help them discover, connect, and use the information. And then in terms of making that information accessible to a wider readership, we have tools like Semantic Scholar, Scholarcy, you know, the software that I've developed, and MathPix that can then help sort of explain stuff about what's going on in the paper, link it through to background reading and so on, reformat that content in a way that's more accessible to, for example, neurodiverse readers, or to people with other difficulties in grasping the content that typically is presented still in, unfortunately, PDF format, which is hard to read on screen. So there's an overview of the ecosystem, but how are these tools actually built? So if I'm running out of time, just let me know, but I will share these slides after. But there's two ways that publishers can build AI solutions. They can build them from scratch using their own data. And there's a whole bunch of open source tools that allow these systems to be built, which is really great, because, you know, in the 90s, it was really hard to build this stuff because there weren't the libraries and tools and data sets available that there are now. There's some great innovations by companies such as Hugging Face with their transformers model that you can train, you can reuse, you can build on top of. You can use systems like Spacey and use language models such as Cybert or SciSpacey, specifically in the biomedical domain, to build a classifier model, to build a translation model or a summarization model. All these different systems all use the same kind of core architecture of this thing called transformers, which has really I'd say it's revolutionized natural language processing in AI in the last 5 years, because it can also be applied to computer vision as well as text. But if you don't want to build your own system, then you can use existing services. So you'd bring your own data, or you'd use some existing open access data sets. And there's tools, most famously GPT-3 from OpenAI, which is being used in many, many ways at the moment. But there's also tools such as Auto NLP from Hugging Face. And there's the open source version of GPT-3 from Eleuther.ai, which is called GPT-J. And these massive, massive language models basically provide the world knowledge, if you like, at least the world knowledge according to the internet, about how language is used and connected and referred to and spoken and so on. And then you use that as the basis for your model. It provides that kind of, those building blocks for building a more complex system. And you can leverage tools such as SageMaker from Amazon, or other APIs such as Semantic Scholar or Scholarcy, and you can use them out of the box, or you can build on top of them. You can take their output and then refine it, classify it, and so on. So there's a really big ecosystem out there, and it's growing all the time. It's a really exciting time, I think, to be using AI in scholarly publishing, because there's always new tools emerging, and we're seeing that kind of cross-fertilization of ideas now. I think, as Joris will say about what's going on now with the STM, about bringing things together across publishers to build tools that will benefit the community as a whole.
Joris, would you like to take it from there?
Yeah, I think a lot of great examples of tools. Some of them I even didn't know myself, so that's great to see. As you started, I mean, one of the ways that AI is being used is basically to analyze the millions of articles and books that, you know, it's just simply too much information for single individuals to process, and AI can certainly help there. And there are various tools, as was shown previously, that can help there. There was an article a few years ago in Nature, and I think they had a nice way of putting it, is taming the scientific literature, which I thought was a nice way to describe it. It does have one problem, though, and it is that we are still in a phase of a narrative-based science. Most of what we produce is written in articles and books. And of course, narrative-based science is not optimal for AI. AI has still great difficulty. NLP, of course, tries to help there to analyze and to make sense out of content. Look, for example, at the disappointing results of IBM's Watson. I think that was divested yesterday, the news. So what we need really to fulfill the promise of AI is not only, you know, the expanding these tools, but also shift from a narrative-based science to a data-based science, because the real promise for AI is really in the underlying data. And of course, in the last decades, we have seen an exponential growth of experimental, observational, scientific data, and it's there really that the potential lies. So we as publishers, we have to help that shift from narratives to data. And one of the things we do at STM is the Research Data Program, basically supporting publishers to roll out tools to help authors to share, link, and cite, basically make scientific data accessible to humans, but also in the end to machines. And again, it's there where I think the real promise of AI lies.
I want to very quickly talk about challenges, because it's always important to talk about challenges when it comes to any sort of solution or technology that's out there. AI is certainly proving to become the new norm for intelligent dissemination and consumption of academic research and professional content, and clever optimization of it will certainly play a vital role in the success of the publishing industry. But no technological evolution is without its own, own set of obstacles and challenges. So in that light, Joris, maybe we could start with you. What adoption challenges have you personally experienced, or what adoption challenges are to be experienced or to be foreseen when it comes to operationalizing the previously mentioned?
Yeah, I think there are several challenges on several levels, and I want to highlight a few of them. First of all, it's a complicated arms race, and look at paper mills, for example. They're using really sophisticated technology. So we as publishers, we have to counter that and basically answer the challenge on the level of technology. And again, it's collaboration which is really needed there, hence also the Collaboration Hub initiative. I think another challenge is that you have publishers of all sizes and all shapes, and some of them will have the resources financially, but also in terms of expertise to think about AI. I mean, what we saw from Frontiers is very, very impressive, but not all publishers will be able to invest that kind of time and energy in that. So we have to make sure, as STM and as a community at large, that all the publishers will have the same access to these tools, because otherwise, of course, all the fraud will go basically to the place with the least resistance, which is something we have to avoid. So collaboration is really key here, and that's really what we try to do with STM. I also want to talk about another, and maybe share my screen for this, another challenge, which has more to do with, let's say, ethics. For the promise of AI to be fulfilled, and again, really to improve science and technology and in the end society, AI has to be grounded in the values of trust and integrity, which of course are core to scholarly communication and scientific publishing. In order to further advance this, we at STM, we had a working group with various representatives from publishers, basically looking at how AI can be deployed, can be developed in an ethical and trustworthy way. The result is a white paper which we published earlier. Well, actually, it was already last year in April. I think I'll be able to share a link in the chat and in the chat session, basically developing these best practice principles for a trustworthy and ethical AI. And there are various elements that are play an important role here. And of course, they are recognizable for other areas where AI plays a role. It has to be transparent and accountable. Of course, quality and integrity are very important aspects. And again, also there, publishers play an important role as providers of this trustworthy data. Things like privacy and security have to be secured. And it has to be fair. And maybe just to finish off with, I think is a big challenge here, is that we talked about how AI works, right? It strengthens existing patterns. And there's a risk there because strengthening patterns doesn't always necessarily help science. Science really evolves by new insights, by new ideas, by innovation. And if we rely too much on a technology that looks at existing patterns and try to predict the future based on these, we run the risk of making science too conservative. So I think we have to be very aware when we use it. For example, in the peer review process, we have to be careful, not look at the past to predict the future, but also let new ideas and new innovative concepts play a role. Hence, I would say the general principle of AI, again, huge potential, but let's make sure it is used as a smart technology supporting creative individuals. And this white paper is also written in order to make sure that that happens.
Thank you, Joris. Phil, did you want to jump in? And also maybe one of the things that I would really like to also bring into discussion is the implementation costs versus the uncertain return on investments. So perhaps if one of the panelists could also treat this during the discussion, that would be fantastic. Phil, did you want to take over?
Great, thanks. I think it's a really good point about data being more important than the narrative text, although maybe they're not always, as I'll discuss in a second, but also the ethical stuff and biases. I think I just saw a question in the Q&A about predicting the impact of a paper based on its content, and I think certainly AI could probably be used to do that, but we have to be really careful about baking in existing biases about what types of paper are already successful and not, accidentally screening out new and exciting research just because it happens to be written in a different way. In terms of the challenges and the costs and that you mentioned, Sally, I mean, there's always a dilemma about how much to bring in-house in terms of skills and teams and how much to outsource, for example, to external partners. One thing that publishers really do bring is the domain expertise, in the editorial, the workflow, and the product knowledge. And external partners can bring in best engineering practices and technical capability. One thing that struck me about this is back in when XML was a new thing, I remember many publishers would regularly send staff onto XML training courses, and there was something called the XML Summer School that runs every year in Oxford, for example. And perhaps we now need something similar for AI, a sort of AI boot camp for publishing staff to get them up to speed on at least what they need to know enough about how AI can be used and what the sort of issues are. In terms of costs, I think potentially costs could come down because we're seeing a lot of data sets and models and algorithms now in the public domain. Most new research on AI, including the code and the trained models, is now open source and open access, which is great. I still think it's important, though, to bring in a technical partner who's got a track record of delivering AI solutions, because, you know, as Joris touched on, it's despite recent advances, it's not simply a question of throwing data at an algorithm and expecting a solution just to magically emerge. What we tend to find is when you're building a system that the best systems tend to combine machine learning from data and also expert rules, so domain-specific rules or ethical rules or whatever type of thing that you want to add to the system to make sure it actually does what you really want it to do. And so there's still an art as much as a science, really, in building a good AI solution. I think the challenge for publishers is that, you know, you still got great content, and the main challenge is really how best to make that content discoverable, reusable, but also accessible to a wide readership. AI can be part of this, but it's not necessarily the whole solution. If I could draw an analogy between what people talk about in the startup world, for example, startups are often advised to say, you know, to begin with, do things that don't scale. This means that, you know, prototype a solution, see what it might look like, how might it be used, and how the content might be transformed into what you want. And do this without using any AI at all. You know, you can be a manual process. You think, what would I really like to do with my content and my data? How would I like it to go from A to B? And you sort of build around that, prototype that before you bring any AI into it. You know, from my own experiences, for example, building Scholarcy, the first version had no AI at all. It was really more about imagining what would research content look like if the content was transformed in such a way that an average reader could make sense of it, or what would it need to look like for a neurodiverse reader or someone with dyslexia in order to have the information they need broken down into bite-sized chunks that encourages exploration, linking, or following trains of thought. So I think, you know, before you go into AI, just really sort of think about the type of solution you want, who the audience is, what you want it to look like, prototype it, mock it up, and then start looking at maybe how AI can then help you get to that point faster. That would be my recommendation, really, in terms of overcoming those challenges.
Thank you, Phil, for that. Mara, maybe you have some thoughts to share with your work with IRA in terms of challenges that you've also come across. What are your thoughts?
Yeah, I can only echo really what Phil said about this idea of, you know, you need to know first what your processes are before you bring any technology in. And that's exactly the way we do it at Frontier. So we have had the advantage, we were started as a sort of technology company. So we have our in-house technology team. And I think what we need to distinguish a little bit is the usage of these AI tools or you know, these types of plugin modules that can be released and people use it and they want to maybe understand the assumptions the type of modeling makes, how it was trained and so on, versus actually evolving the technology with new approaches, basically. And that's a little bit where we sit with Frontiers. You know, we are co-evolving with the technology. And so it's an investment for sure, with sometimes uncertain payoffs in terms of really how much it can speed up things or take over certain manual tasks to really focus the teams and the editors and the reviewers on the scientific content, rather than getting them too involved in routine checks, so to speak. I would like to touch up, so there is a whole culture around using this type of technology in an organization, and that has something to do with having a vision for it and having support right from the C-suite, so from the top level right down to the assistants that work day to day with the technology, and they need to give feedback. So when we, you know, years back now started introducing the IRA flags for our teams, it was hard work for them, for sure. So what happened is that they needed to do their day job, their usual processes, and in addition, they needed to check what the AI was recommending and giving feedback on top of it. And most of the time it was wrong. So it was learning still, and we went through a lot of iterations. So it was the workload on the team in the initial phases is actually quite heavy. Then you learn as you go, you get more efficient, but there's also a whole cultural aspect of being able to evolve this type of technology in-house. Then I think we touched upon the other major points about challenges is the data availability, data quality. So we're still grappling with paywalls, not standardized data models and objects, content deposition strategies that are different between different publishers, and then the bias that we introduce through either the training data sets or the algorithm itself. So that's, of course, always a risk. We have that with people too. Handling editors recommending their own reviewers. Bias cannot be eliminated. It's about being conscious of it and having checks around it to ensure you don't drift. So those are sort of the major challenges. But yeah, if I could add something to the discussion, it's really was around the cultural aspect of working with AI in an organization.
Mm-hmm. Right, because it is a transition. And finally, before we hop onto the Q&A, I see a couple of questions. And also, again, this is a reminder for the people who are commenting on the comments section. If you have questions, please use the Q&A section to address your questions. I would like to talk about the future. So according to TWI Publishing survey in 2021, only 31.2% of publishers are currently making use of any AI technologies, and 68.8%, so nearly 69% believe that it will play a key role in the future. What trends are to be expected in terms of future publisher spending on AI? Phil, would you like to go first?
I'll be happy to start. I think in terms of using AI, I think Joris touched on this in terms of the process for STM papers. Validating the process from the research lab to the reader will continue to be important, and that goes beyond the narrative. That's all about the data. So I think we'll need to go beyond taking the manuscript at face value and go further than using the manuscript as a single source of truth for a piece of research. And so in biomedical research, that might involve linking to electronic notebooks that the researchers used, published protocols, making use of data sources to help verify the manuscript and what finally gets published. So it's about using a wider pool of data than just the manuscript and just the paper. In computer science, we're starting to see this already. There's sites such as Papers with Code, and there's other sites that produce executable papers where you can actually rerun the analysis and rerun the algorithms to check the results, actually match what the authors are claiming to have been able to do. But there's more to research than biomedical papers and computer science papers. There's a whole world of social science research and the arts and humanities, and that stuff's really important too. And I think it's important not to leave those subjects out of the equation. In something like grounded theory, writing the manuscript is as much a part of the research process as working with the study participants themselves. And the research output is more of a collaborative piece. And so maybe in those sort of areas, it might be harder to see how AI might help in future beyond maybe what we're currently already doing, which, in terms of checking the structure, the references, checking for plagiarism, doing the grammar checks and so on. So, I'll be interested to hear what the other panelists think about social science, about how AI can work in the humanities.
Yeah, absolutely. Maybe Mariam or Joris can take it from here.
Yeah, maybe give you my thoughts. I think the trends depend very much on what kind of applications you're talking about, right? So, on the one hand, you have the trend of systemic misuse and manipulation, often used in high tech, and this, of course, really spurs innovation. So publishers have to answer it. So I think that's an important driver for AI to develop in this area, and we've seen some very good examples today. Another one is editorial efficiencies. AI can really help with streamlining submissions, checking, doing some technical basic checks on articles, even helping, of course, with automatic language editing. So there, I would say it pays itself back. So I think that's a different dynamic. On the other level, on providing content, and again, to stress that publishers are really capable as no other. It's really our expertise to make sure that the right content with the right format is is selected for AI. And this requires continuous investment, also from the people using it. So I think that's also an important thing to stress, that high quality AI needs high quality data, and high quality data comes with a price. So I think as a general community, as a publishers, but also as the users of AI tools, we have to be aware that this investment is really required for responsible and effective AI. So
Sure,
complex answer for actually a complex question.
Right, and Mario, maybe you could kind of wrap up things there.
Yeah, I agree with everything that's being said. Of course, there is a huge responsibility in ensuring that we're keeping on top of this arms race, as was mentioned a little bit. We've always been in it. I mean, how humanity has existed, it has always been the person who cheats, the person who cuts corners. So it's an unfortunate part of the reality that we live in, but we obviously feel a great sense of the scientific integrity of the literature being of utmost importance, because it has implications for society, for health, and so on. So there are really downstream consequences. And AI is for sure our next tool in the toolbox regarding these types of infringements. But what I maybe want to bring it back to a more positive point is really, like, as publishers, for us, it's also about providing a great author service. And the researchers produce this type of knowledge, and they want to disseminate it in a rigorous and widely read manner. And that is really something that we see as our core value proposition, is to enable that through technology as well, to provide this great experience of what comes after a long research process, is to actually share the results with the world. And there, of course, we are, maybe more concretely for Frontiers, we're looking, of course, how people might interact with Ira, how she can give feedback to people. And the technology evolves even then to enhance the researchers themselves. So what I find really exciting in the future about technology is not just sort of the Spotify of research articles, but also to synthesize and interpret scientific findings on a meta level, and to draw conclusions from now a body of literature that is difficult to digest for humans, and to find these connected themes and conclusions that we can draw from it for the first time. I think we have this technology at our fingertips that can really make sense of certain research advances and come to newer conclusions, in addition to the researchers themselves. So that's, my exciting final note.
We have 7 minutes, and maybe we can hop onto the Q&A. I will take maybe 2-3 questions from the Q&A section. And again, there's an invitation for everyone who might have questions to kind of type in your questions there. So Julie has an interesting question. Given the increasing number of publications getting out there each year, what are your thoughts about alternative publication formats such as nano publications, and how would they fit in the AI landscape? Would one of the panelists like to take this question?
Yeah, I'm in touch with some people who are building these nano publication type platforms. There's Octopus, which is a recent grant holder from JISC and a few others, and the idea is that authors publish their hypotheses and methods and so on as discrete chunks, and people connect them together, and this is all open and public. There's a few other systems like that doing this sort of nano publication thing. In terms of how that fits in with AI, I think one issue that Octopus has is, how do you seed this process? How do you encourage people to submit nano publications where none previously exist? So there's this idea maybe that AI could help break papers down, existing papers, into their core components. What were the key methods? What were the main findings, and so on? And can that be atomized and connected together in some way? So I think there's a role of AI in nano publications in that way, in breaking down existing research and connecting it up as a sequence of facts, for example. That could be a viable route. And I know there's companies doing this. It's quite hard to do this in practice because language is ambiguous, but maybe at least breaking down the chunks into methods, results, and so on, and have those as miniature publications, linked to a figure or something on a table, could be something that AI could do.
Thanks, Phil. Julie, I hope that answers your question. This question is for you, Mariam. It's a kind of a technical question regarding IRA. I wonder how accurate image manipulation detection and how fast it can detect from IRA.
Yeah, so the accuracy is difficult, right? Because even if you spot some sort of similarity, there might be a good reason why, and you will only know that if you read the figure legend and so on. So AI can obviously not quite put this into context in terms of whether the manipulation that it might detect in terms of the sense of, okay, it was it was replicated somewhere, or it was it was rotated. That is still a human part to it. So it's really difficult to give you a number for the accuracy, because of course it's doing its job. It's just whether it's doing its job in the context, or whether it's accurate in the context of the scientific part of this paper and what it shows. That is really hard to say. The idea, of course, is just to direct our teams currently to manuscripts that need that type of additional validation, and to let papers through that don't need it. So there's this type of triage situation right now where we are trying to be more efficient. It's not so much about the algorithm or the AI to be 100% accurate. I don't think that's the point here.
Okay, so maybe one final question. Is there any AI-based tool for systematic literature review? I think they're asking for.
I think there's quite a few, actually. Yeah, I think most of them are commercial. I don't know the names of them off the top of my head, but there's. It depends which aspect, I mean, there's the searching side of the literature review, there's the screening of the papers and so on. So I think there's different tools for different parts, but there are a number of tools available for that. Yeah, I can't, off the top of my, I can supply a written answer to some of these answers if you like, but.
All right.
Yeah.
Okay, well, thank you for the panelists and the audience. This is a reminder that the replay will be made available on YouTube, so that is on My Science Work YouTube channel. I hope to welcome you here again on the 29th of March with another interesting discussion with another group of experts on the topic of open access publishing models and reimagining tomorrow. The idea is to kind of talk about the new open access models and the shift from closed to open access, which is an opportunity to think out of the box and imagine new open access models. So please stay tuned for that. That will be communicated as usual on the My Science Work social media channels. So My Science Work Twitter, LinkedIn, and Facebook. So you can follow us there. Thank you once again to the panelists for your precious time and valuable insights. And thank you everyone for joining us today from around the world.
Thank you, Sally.
Thank you.
Thank you.